So the next topic is reviewing negative and fractional exponents and how to simplify expressions involving those. So basically we're going to use our regular exponent rules, which are these three main ones here, that when we have a product of a base to a power times the same base to a different power, we add the powers. When we have a quotient of the same thing, we subtract the powers. When we have x raised to an exponent and that whole expression raised to another exponent, then we multiply the exponents. We also have this idea of a negative exponent, and what that does is it just makes us take the reciprocal of that expression. So a to the negative n will give us 1 over a to the nth power. Okay, so here's just a simple example with fractional exponents. We have 2 to the 1/2 times 2 to the 3/2. So by that first rule, we're just going to have 2 to the 1/2 plus 3/2. So we'll have 2 to the 4/2, which is 2 squared, which is 4. Right, so this is how we apply one of these exponent rules, is we just don't get freaked out at the fractional exponents and just treat them like regular numbers because they are, and we're just going to add them if the rule says to add them, and not worry too much about them. Here it ends up being a whole numbered power of 2, and we just have 4 as our answer. Now we might have something like this, where we have powers of variables. So now we have two different bases, and we have to think what are we going to do with this 1/3 power and the other exponents involved? Well, if I'm taking everything to the 1/3, that's the same as taking x to the -3 to the 1/3 and y to the 6th to the 1/3. Right? So now I can use my third rule that I see over here, and I'm going to multiply those powers. So I'm going to have x to the -3 times 1/3, so negative first power, times y to the 6 over 3, right? 6 times 1/3 gives us 2, so times y squared. And now x to the negative first power, if we use our a to the negative n rule, really means that we have 1 over x to the first times y squared. So this gives us y squared over x. So we'll know that something's simplified if all of the exponents are positive. We want to make sure that we move things to the denominator that need to be moved, so that we don't have any more negative powers like we did right here. Okay, let's do one more example. Here we have a slightly more complex example. So we have this whole ratio all to the negative first power. So one thing I could do is I could say, well, if I have something to the negative power, it's really 1 over this whole thing. So 1 over x to the 1/2 over x to the 5/2 plus x to the 3/2. Right? And this is all to the first, so really I'm not doing anything to that now that it's to the positive first power. So I'm going to just get rid of that. And now if I'm dividing by a fraction, it's the same as multiplying by the reciprocal, so really I have x to the 5/2 plus x to the 3/2 over x to the 1/2. Right, times 1, but that doesn't do anything. Okay, and now is there anything I can do? Well, I can't add these, right? We don't have a rule that tells us we can add. We just have a multiplication rule a quotient rule and then an exponent to another exponent rule. So one thing I could do is I could split this up. I could say this is x to the 5 halves, or 5 over 2, over x to the 1 half, plus x to the 3 halves, over x to the 1 half. And now I can apply my quotient rule. I can say this is x to the 5 over 2 minus 1 over 2, plus x to the 3 over 2 minus 1 over 2, which is x to the 4 over 2 plus x to the 2 over 2, or x squared plus x. And now here we can see that there's nothing left that we can do, so this is simplified. So to get from this expression to here, we just have to follow whatever rule we can see to apply there. So we just have to make sure that we know those exponent rules to apply them.